Okay, so again, we're going to solve this rational inequality right here. Again, that's example 6 for the kids at home. That's example 6 on page 604. But before we do that, again, I want to remind you about a couple things about inequalities. The first thing is, let's say you're solving an inequality that looks something like this. Like, let's say you got, I don't know, negative 3x is less than 15. So if you're going to solve that inequality, you would divide both sides by whatever number is in front of x. The negative 3's would cancel and make a 1. You get x on the left-hand side, and on the right-hand side, you'd have 15 divided by negative 3. That'd be a negative 5. But then what's the thing I got to remember to do with this thing? Do you remember? When I divide both sides of an inequality by a negative number, I have to do what? Yeah, you got to flip the inequality symbol or switch it the other way. So right now it was this was a less than. We want to switch it to be greater than. So that would be your solution, all the real numbers x that are greater than negative 5. Now, did anybody ever show you why you do that, why you flip it? Does anybody know why you flip that thing? I mean, I'm sure they showed you to flip it, but I don't know if they ever told you why. So let me show you really quick. So let's say if I wrote something like 10 is less than 20. Is that true? Yeah. So 10 is definitely less than 20. Well, let's say I divide both sides of that by negative 5. Well, now on the left-hand side, I've got negative 2, and on the right-hand side, I've got negative 4. Which one's greater, negative 2 or negative 4? Yeah, the number that's farther to the right on the number line is the greater number. So actually, this ends up going this way, right? You end up flipping it because negative 2 is greater than negative 4. Does that make sense? That's why you flip it. All right? Even in the ones where you have x in there, it's still the same concept. X just represents some real number, right? So you still have to flip it. Or same thing if you do like, let me erase some of this. Same thing if you were to multiply both sides by a negative number. So if you have an inequality, excuse me, and you multiply both sides by a negative number, let's say I multiply both sides by negative 2, then on the left-hand side here, I'd have negative 20, and on the right-hand side, I'd have negative 40. Which number is greater, negative 20 or negative 40?
Negative 20?
Yeah, negative 20 is further to the right on the number line. So you got to flip it the other way. So negative 20 is greater than negative 40. So anyways, that's just my little introduction to inequalities. Well, let's see how that's related to what we have to do now. So let's go over here and solve this thing. Let me write this problem down. So what are we trying to do? We're trying to do 8 over x plus 5 is less than or equal to 4. Okay. All right. So let me see if I can zoom in a little more here. So what we want to do on this one is we want to solve for x, right? Well, if we're going to solve for x, actually let me write this thing a little bit smaller. I don't want to really take up that much room here. So what was it again? 8 over, was it x plus 5? Was less than 4?
Greater than or equal to 4?
I don't know, I don't remember. Less than or equal to. 8 over x plus 5, less than or equal to. Okay, gotcha. All right. Yep. Okay. So we want to solve for x. But we can't solve for x when it's in the denominator, okay? If you're going to solve for a variable, it needs to be in the numerator. So how do I get that x plus 5? How do I get that quantity up on top? What could I do?
Times x plus 5?
Yeah, good. Multiply both sides by x plus 5 on the top. So we're going to multiply by x plus 5 on the left. And then we're going to multiply by the quantity x plus 5 on the right. And then you should see that on the left-hand side over here, these will cancel out now. So then you get a nice equation all on one line, right? So you get 8. You get 8 is less than or equal to. And I'll go ahead and distribute that 4. So I'm going to do 4 times x. And 4 times that positive 5. So that's going to give me 4x. And then 4 times positive 5 is positive 20, so plus 20. But actually I should have left this out of here for a second just to discuss it. Take that out of there. I multiply both sides by x plus 5, right? How do I know whether that's positive or negative or not? Because if this quantity x plus 5 is positive, I would leave the sign as it is, right? The inequality symbol would stay as a less than or equal to. But if that quantity x plus 5, again, it depends on what x is, but if that quantity x plus 5 is negative, I just showed you over there a second ago that if you multiply both sides by a negative, then you would have to flip this inequality the other direction, right? Well, it turns out we don't know, I mean, it depends on what x is. X plus 5, that quantity could be positive, or that quantity could be negative. So I got to do 2 cases, all right? So what I want you to do before we finish this is, let's see, where should I fit this on here? Maybe I'll put it over here on the side. So what I want you to do now is I want you to assume, so we're going to assume, that the quantity x plus 5 is positive. Okay? We're assuming that that quantity is positive. Well, that means if I multiplied, so again, this thing right here, I'll put a little note here. This thing is positive. That's what it means when I write that it's greater than 0. Okay, so that quantity is positive. Now, I might have considered whether that quantity was greater than or equal to 0. But I think you can see that I can't have it equal 0, because if x plus 5 was equal to 0, that quantity, then I would have division by 0, and I can't do that. So that's why I just have it. That's why I just have it so that x plus 5 is greater than 0. So I'm saying right here that x plus 5 is positive. Well, if I multiply both sides by a positive, then, that's what I wrote right here, then I do not have to flip this thing. I can leave it the same way that it is. So that means this is still going to be a less than or equal to, and then I can just quickly solve this inequality right here. So I'm going to subtract 20 on both sides. That's 8 minus 20, that's a negative 12, is going to be less than or equal to, the right-hand side is going to be 4x, because the 20s cancel out, make a 0. Then I'm going to divide both sides by whatever number's in front of the variable. So I'm going to divide the right side by 4 and the left side by 4. That's going to give me negative 3 is less than or equal to, the 4's cancel here, and I didn't want to write next. Oh, it turned off, darn it. I keep forgetting to wiggle my mouse. All right, hold on a second. There you go. So I divided both sides by 4. And on the left-hand side, I got negative 3 is less than or equal to. And on the right-hand side, the 4's canceled out, and I just got 1x. Now, normally when we do these, we do not like to write these, like our solution is right here. We don't like to write them with the variable on the right. So I want to switch this statement around right here so that the variable's on the left. So if I do that, I'm going to put the x on the left. I'm going to put the negative 3 on the right. But then I need to make sure that I put my inequality the same direction that it is, right? So right now, if you look at it, it's pointing towards the negative 3 right here, right? So when I rewrite this, this is an equivalent statement. I'm still going to have it pointing towards the negative 3 like that. All right, so these are the same. These are equivalent. To say that negative 3 is less than or equal to x, That's exactly the same thing as saying x is greater than or equal to negative 3. All right, so far I know that if I solve this thing, and I assume that the quantity x plus 5 was positive, I get this solution right here so far. I got x is greater than or equal to negative 3. But at the same time, you got to solve this thing right here where you made that assumption that x plus 5 was greater than 0. So very quickly, I also want to solve that. So I want to subtract 5 on both sides, and I get x is greater than negative 5. Okay, so now, when I solve this first case, I guess I could call this, this is case number 1, if you want to think of it that way. Case number 1, we assume that the quantity x plus 5 was positive, or greater than 0. When we solve this case, now when we look at the solutions we have, we want the real numbers x that make this original inequality true, and at the same time make this assumption right here that x plus 5 is greater than 0. We want to make both of those things true at the same time. So we want to make this inequality true, and we want to make this inequality true. So basically it's an and, okay? We want to make the original equality and our assumption true at the same time. And an and is it's an intersection. So what we need to do is we need to graph both of these inequalities that we ended up with here, and we need to look for the intersection or the overlap when we graph those on a number line. So I'm going to graph these on a number line real quick for you guys. So we're going to make a number line like that. We need to put two numbers on there. We're going to put negative 3 and negative 5 on there. We don't got to get real fancy about scaling this thing. We just got to make sure we put them in order left to right. So you would have negative 5 would be here, and negative 3 would be here. All right. And then the first one I'm going to graph is this one. X is greater than or equal to negative 3. So I don't know if you guys remember this stuff. This would be since it has the equal to bar on there, we would make like a solid dot. So we would make a solid dot at negative 3. And we want where the x's are greater than negative 3. So that would be we would shade it to the right. So we would go like this. All right. And then for the second inequality we have right here, there's no equal to bar on this one. So we would use like an open circle or an open dot. So we'd put an open dot at negative 5. And again, we're looking for the x's that are greater than negative 5, so those are also to the right. So we're going to shade to the right of negative 5 like that. Now, what I told you a minute ago is we want the solutions to this inequality and this one. So the and is, again, the intersection or the overlap or the double shaded part. So how would you describe where this thing is double shaded? This number line that I just drew. You can see here it's not shaded in at all. In here it's only shaded once. These x values between negative 5 and negative 3, those are only solutions to this inequality over here. So where's the double shaded part? How would you describe that? X is what? X is, where is it double shaded? Where is it shaded twice?
Negative 3.
Well, to the right of negative 3.
Yeah.
Can you guys see that? So it's double shaded over here, right? To the right of negative 3. So that would be where all the x's or all the real numbers x are greater than negative 3. And then because you have the solid dot at negative 3, that would be including the negative 3. So you'd have to put that equal to bar back on there like that. So that's actually your solution for that part. That's for case number 1. Now hopefully I can go a lot quicker now that I kind of laid all that out. But now we got to do case number 2. That's why I'm only assigning 3 of these problems for you guys. So let's see if we can do case number 2. So let me come down here. So for case number 2, again, we're going to put our inequality here. It was 8 over x plus 5. What was it again? Less than or equal to 4? Is that correct? That should be our original problem, right? 8 over x plus 5 is less than or equal to 4, yes. Okay, now this is going to involve all the same steps. So to start this one, we are going to multiply both sides by the quantity x plus 5. We can't solve for the variable when it's in the denominator, so we need to get it on top. But this time when we do it, we're going to do case number 2 here. And case number 2 is we're going to assume that the quantity x plus 5 is negative or less than 0. Okay? So what I just did then is I just multiplied this side right here. This is a negative. Well, if I multiply both sides by a negative, then I'm going to have to flip this inequality in the middle, right? So let's do this. So these quantities x plus 5 on the left are going to cancel out still. So that side is still going to be 8, just like it was before. I'm going to distribute the 4 on the right-hand side, just like I did before. So that is going to give me 4x plus 20. But since this quantity x plus 5, since we assume that it was negative, if I multiply both sides by a negative, I got to switch the inequality or flip it the other way. So this is going to become a greater than or equal to. Now we're going to quickly solve this again, which we just did a minute ago, so it shouldn't take too much. So we're going to subtract 20 on both sides. The left side is going to be negative 12. That's going to be greater than or equal to 4x because these 20s are going to cancel out. Then I'm going to divide both sides by 4. So I divide both sides by 4. And then on the left-hand side, I get negative 12 divided by 4 is negative 3. I get that as greater than or equal to. These 4's cancel out, and I get 1x. Again, I don't like having the x on the right-hand side of that inequality, so I'm going to write it on the left-hand side. I'm going to put the negative 3 on the right-hand side. But as you can see right here, this inequality is pointing towards the x. So when I rewrite it, I need to rewrite it so that it's still pointing towards the x. There we go, we got that done. Then we still got to go solve the little inequality we wrote for our assumption right here, that x plus 5 was negative. So we're going to solve that one real quick. So we're just going to subtract 5 on both sides, and we're going to get x is less than negative 5. Well, again, now what I'm looking for here is I'm looking for the solutions to this inequality right here, the original inequality. I'm looking for the real numbers x that satisfy that inequality and the inequality in our assumption. And again, when I use that word and, that means I'm looking for the intersection or the overlap. So I'm going to draw a number line again real quick here. So I draw my number line. I put my two numbers on there. I got negative 5 and negative 3. Again, they don't need to be scaled really fancy. I just got to put them in order left to right. So then I have this inequality over here on the left. That's the real numbers x that are less than or equal to negative 3. Because I have the equal to bar, I need to put the solid dot at negative 3. And it's the x's that are less than negative 3. So I would shade to the left of negative 3, like that. What's that? Oh, yep, you guys got to remind me. I keep forgetting to move my mouse. All right, so let's see. I think I typed my password in wrong. There you go. All right, so we were just shading this one in. Okay. So again, we have the equal to bar here, so we have to put the solid dot at negative 3, and then it's the real numbers x less than negative 3, so that would be to the left of negative 3. And then we have to graph this one also over here. X is less than negative 5. This one does not have the equal to bar, so I make an open dot at -5. And again, those x's are less than -5, so I would shade to the left, like this. So where's the double shaded part on that one?
To the left of -5?
Good, yeah, to the left of -5. So what I get again, I'm solving both of these inequalities at the same time. I want to find the x's that make this one true and make our assumption true at the same time. So that is the double shaded part, and what Kyle said was correct. That would be all the x's that are less than -5. Okay, and there's no equal to bar on here because we've got the open circle there at -5. Now, we just solved, this was the solution for, we're almost done. This was for case 2, right? That's for case number 2. And then for case number 1, we had this up here. This was for case number 1. This one. Now, to finish it, we want all the real numbers x that make case 1 or case 1 true. Now notice I use the word or, not and. So if you use the word or, we want the solutions to case 1 or the real numbers that are solutions to case number 2. That means we're going to take those two final solutions we got for case 1 and case 2, we're going to graph those both on the number line. And since it's an or, we're looking for anywhere that's shaded. We're not looking for an overlap. We're looking for anywhere that is shaded. So let's do that. So we got to draw one final number line here. And again, the number line I'm using is, I'm using it based on the final solution for case 1 right here in red right there, and case number 2 right here in red. All right, so let me draw a quick number line for this. We can wrap this up. Got to get some room here. Okay, so here we go. Here's my number line. All right, I got to put -5 and -3 on there again. So I got -5 and -3. The top one up here, this one has the equal to bar on it, so I got to put a solid dot at -3. And it's the x's that are greater than -3, so they would be to the right of -3. So I would draw it like this. And then for this other one down here, these are all the real numbers x. They are less than -5, so there's no equal to bar on here, so it's going to be a open dot or open circle at -5. And again, it's the x's that are less than -5, so that I would shade to the left. So it'll be like that. So that is my final solution right there. Again, I want the solutions, I want all the real numbers x that make this one true or this one true. So that's anywhere that's shaded on the number line. So all I got to describe is what I've got shaded in right there. So let's see if I can get a little bit more room here. That's probably about all I can get. Okay, so then I'm going to write my final answer. Well, I've got to describe these, I got to describe these x values over here. Well, that's all the real numbers less than -5. So I'm going to write all the real numbers x less than -5, or, and then I got to describe this shaded region over here. That's all the real numbers x greater than or equal to -3. So that is my final solution right there. Now, instead of using the word or, I can also use union, means the same thing as or. So you can use this symbol right here. You can use this U like that. That stands for a union, which is the same thing as an or. So that's your final solution right there. Now, just real quick, we know our solution. Let's see if it actually works. So let's say we have our original, I'm going to put my original problem back on here real quick. So my original problem was 8 over x plus 5 was less than or equal to 4. Is that correct? So give me a number. Our solutions are supposed to be over here, right? So give me a number for x that's to the left of negative 5. Negative 6 would work. Negative 7 would work, right? So let's test one of those points and make sure it's actually a solution. So I'm going to test, let's test, I don't know, negative 7. So here's negative 7, right? Nope, let me a different color. So here's negative 7. So if I put negative 7 in for that x, so right here, if I put negative 7 right here, that should make a true statement. Well, let's see, on the denominator, I got negative 7 plus 5. Negative 7 plus 5, that would be negative 2. 8 divided by negative 2 would be negative 4. Is negative 4 less than or equal to 4? Yeah. All right. Well, also, we said or any point over here to the right of negative 3 would be a solution, including negative 3 because I got the solid dot there. So give me a number over here somewhere.
Negative 2.
2 would work. What would be a really easy one to the right of negative 3? What's like the easiest number to plug in? What's that? 0. Yeah, 0 would work. So let's test 0. So 0 would be about right here. So we're going to test 0. So if I plug 0 in for my x, so I'm going to plug 0 in right here. In the denominator, I got 0 plus 5, that's 5. 8 divided by 5, that's the same thing as 1 and 3/5, which is, what, 1.6? Is 1.6 less than or equal to 4? Yes or no?
Yeah.
Yeah. Yeah, so our solution is good. That was just a quick check of it. All right, so what I'm going to add on to your assignment then from this part is still going to be in section 8-5. So it's still on the same page you were on yesterday. So this is going to be page, so it's still page 605. But I'm going to add on numbers 16 through 18, which is exactly what we just did, okay? It's 3 of those problems.